Hello guys, welcome to the DMS Online School. In today's video, I'm going to teach a physics lesson, and this is the first lesson in physics on the topic known as general physics. So it is very, very important that you understand this topic very well because most of the time people fail to understand physics or find physics very hard because they fail to understand this topic. All right, so if you're not going to watch this topic up to the end or this lesson up to the end, then it will be very hard for you to understand physics. Therefore, I encourage you to watch this video up to the end. All right. So the first topic in Zambian syllabus physics is known as a general physics. So we are going to look at the general physics. All right. So this is the first topic, general physics. All right, so that is the topic. So you know, whenever you are studying something, it is very, very important that you understand the definition of what that something is, because in that definition, that is where the concept also lies. So we are going to look at what physics is. All right, so we'll define physics, and from that, you will be able to understand certain concepts that will help you throughout your study of physics to understand what physics is. All right, so let's define what physics is. So this is the definition. We say physics is a branch of science which deals with properties and interaction interaction of matter and energy. So that's what physics is the study of um, is the branch of science which deals with the properties and interaction of matter and the energy. So whenever we are studying physics, it means we are studying the properties and the interaction of matter and the energy. So these things must interact. That is the properties of matter and the energy. Okay. So now it's very important we understand this concept which we are calling properties of matter. So when we say we are studying properties of matter, what are we actually looking at in physics? So when we talk of properties of matter, we are talking of physical quantities. So properties of matters are physical quantities. Okay. So we are saying these are physical quantities. Okay. Now, if we are saying properties of matter are physical quantities, then what are physical quantities? So physical quantities are just uh, measurable properties or features of objects. So we are saying physical quantities are measurable properties or features of objects. So the physical quantities are measurable properties of or sorry, or we're saying these are measurable properties or features of objects. So this is what these um, physical quantities are. So in order to understand what matter is, physics deals actually with the measurement of physical quantities of the observable universe. So physics will deal with measuring these physical properties of the observable universe. That's what physics does. Therefore, we are going to say, therefore, physics deals with the measurement of um, measurable properties of the observable universe. So whenever we are studying physics, what should come in our mind is that we are dealing with a measurement of measurable properties of the universe, or rather measurement of the physical properties of the universe. So now, to just make you understand, what are these measurable properties of the universe we are talking about? So examples of measurable properties of the universe include, so we can talk of these things like one, we can talk of time, so we can measure time in the universe, okay, we can talk of length, we can talk of mass, we can talk of speed, we can talk of energy itself, we can talk of force, we can talk of temperature, etc. Now, I've given you a clue or an idea of what these measurable properties of the universe are. So they can be length, I mean time, length, mass, speed, energy, force, temperature. When we are studying physics, these are the things mostly we measure for us to understand the universe very well. Okay? So that's what usually physics is all about. So we measure time, length, mass, speed, energy, force, temperature, etc. These are the measurable properties of the universe that we look at whenever we are dealing with physics. Okay? So these physical quantities are categorized into two categories. So the physical quantities of the universe, which we measure, like these are listed below, they are categorized into two categories. Okay, so let's talk about the categories. So we are saying physical quantities are divided into two categories, namely, we have those that we call basic quantities or base quantities, and those we call derived quantities. So we have category number one, we can call it base or basic quantities. Then category number two, we call it derived quantities. So now let's look at what we call base quantities. So now what are these quantities? So base quantities are quantities that cannot be expressed in terms of other quantities, or that cannot be described in terms of other quantities. So we are saying these are quantities which or that cannot be described in terms of other quantities. So that's what base quantities are. So whenever we are describing these, we are not able to describe in terms of other quantities. We just describe them the way they are. Okay, we'll look at what they are very soon. And then let's look at derived quantities. So now what are derived quantities? It is the opposite of what we have stated here. So we are saying these are quantities which can be described in terms of other quantities or basic quantities. So we are going to say these are quantities that can, this one they agree, so we can say that can be described in terms of other quantities. or we can say or base quantities. So this is what derived quantities are. So let me just give an example. So look at the table. So examples of base and derived quantities. So look at the table. This is the table that I'm going to have. So here I have base quantities. Then here I have derived quantities. So let me just create something like a table like this. Okay, so I'll be listing out. Here we have what we call length. Okay, we have also, okay, I'll list them like that. Time, we have mass, we have temperature, we have light intensity, then we have amount of substance, and then we have also and current. So these are examples. They are supposed to be seven. Let me count. 1, 2, 3, 4, 5, 6, 7. So we have length, time, mass, temperature, light intensity, amount of substance, and then current. These are what we call the base quantities that we measure in physics. And these cannot be described in terms of other quantities. Then in derived quantities that we have can be like volume, density, speed, weight, force, then what else? We can also talk of weight, okay, etc. So in terms of derived quantities, there are many. There are many. So these are few examples of derived quantities. Now, usually you can be so clever or so innovative or so intelligent where you only need to understand base quantities like their length, mass, temperature, light intensity, amount of substance, and current. Once you understand this, then any other quantities that will come across, it should fall under derived quantities and not under base quantities or basic quantities. So it is very, very important that you understand these concepts. So in physics, when we are understanding physics, we are actually measuring these quantities here in physics. Okay, so now let's look at what we call SI units. All right, so in physics, it's very, very important that you understand this concept which is known as units or SI unit. So before we look at SI, we need to look at this word unit. Let me even write it properly. Unit. Very, very important in science. So, what is a unit? A unit is a standard measure to which a measurement is compared, or it is a standard size to which a measurement is compared. That is what a unit is. So a unit, we are going to say a unit is a standard size. So a unit is a standard size to which measurements are compared. So many when they're studying physics, they ignore these very, very simple concepts, which actually makes what physics is. Because physics, it is the build-up of small concepts. When we put them together, then we make what is called the physics. So in physics, you need to understand what a unit is a standard size to which measurements are compared or a measurement is compared. So when we measure something, for example, a distance that we have said, which is maybe equivalent to from my finger here up to here, we all know that this is usually a 1 meter, okay, or a meter. So this has become a unit because whenever we have a length which is up from my finger up to here, that length we call it a meter. Okay. So therefore we are comparing anything that is of this length, it will qualify to be a meter. Therefore a unit now is a standard because this meter now becomes a standard. Whatever we get, whatever length we get, if it is like that, then we call it a meter. So then a unit becomes a standard measure to which a measurement is compared. Okay. So usually when we record a measurement, at the end of a measurement, we put a unit to also indicate what quantity it is. So units are added at the end of a number or a measured number. Very important to understand that. Okay. So we are saying a unit is added at the end of a measured value or quantity. Okay. A unit is added at the end of a measured value. Now, why is it important to add a unit? at the end of a measured value. The unit enables us to identify what physical quantities we are measuring. Okay. So for example, we are saying a unit enables us to identify the quantity or the physical quantity being measured. So that's what units do. They are there to help us identify the physical quantity being measured. Now, if I tell you if I say, e.g., if I say, if I say, if I say, I weigh 60, like that. If I weigh 60 like that, and that's what I tell you, like I weigh 60, you will not be able to understand that. You say, oh, what does this 60 mean? But if I say I weigh or weigh, I weigh 60, then at the end of it I put kg. To someone who understands physics, he's going to understand that, oh, I am talking about mass. When I say I weigh 60 kg, to someone who understands physics and measurement will understand that I'm talking about my mass, that my mass is actually 60 kg. That's how heavy I am, okay? So that's what it means when we add units. So when we add units to a number, they give or they add more meaning. So they're able to tell us what physical quantities we are talking about. So in this case, if I say 60 kg, the physical quantity that I'm talking about is actually mass. Okay. So now let's look at um, the units in which these measurements are recorded. So the units in which these measurements are recorded worldwide are called what? SI units. So the units in which these physical quantities are recorded worldwide are called the SI unit. And SI unit stands for System International. Okay. So we are going to say, therefore, SI units are the internationally accepted standard units. Then SI stands for System International. So we're saying SI stands for System International. So scientists researched worldwide and agreed to avoid confusion in terms of how measurements are done. They sat down together and they agreed that whenever we are making measurement that are to be shared with other scientists worldwide, we have to adopt or agree to certain standard units that everyone must be using. And those units, they were called the System International, and meaning that these were the systems that were going to be used internationally, but we abbreviate it as SI, which is System International. So it is very, very important you understand what these units are, because now going forward, when you measure something, you have to measure it in or record it in what we call SI units. So now let's look at um, SI, S, base SI unit, and then base derived units. So we are going to look at the base SI unit and the what we are calling derived SI unit. Okay, so I was supposed to write this one using blue, but it's okay. So first of all, let's start with these uh, base SI unit. What are base SI unit or basic SI unit? So base or basic SI unit, these are units in which uh, basic quantities are recorded. Okay, so we are going to say that a basic or base SI units are units in which what we are calling basic quantities are recorded. So basic quantities are recorded in units we call base or basic SI unit. Okay, so now um, base SI unit are represented by single units. So base SI units are represented or or expressed by a single unit. So e.g., time is measured in seconds as the SI unit represented, sorry, I think I have to clean this one. Represented by the symbol small letter s, like that. So you see, this is what we mean when we say base SI units are represented or expressed by a single unit. Okay, so they are represented by a single unit, e.g., time we already explained, or I already taught that time is a base quantity. It's a basic quantity. And because it is a basic quantity, then its SI unit is also a base SI unit. And that base SI unit is actually a second. And this second is an SI unit represented by the symbol small letter s. So you have seen this one is a single. Okay, that's what we mean by a single unit. Now let's move and talk about what derived SI units are. So we are saying derived SI units are units in which derived quantities are expressed and and they are usually usually represented by more than one unit. For example, e.g., e.g. we are going to say e.g. Speed is measured in SI unit which is meter per second, represented by the symbol meters per second. Now, when you look at this, you will now see that it is making sense that derived SI units are units in which derived quantities are expressed. Okay, that's what the derived SI units are units in which derived quantities are expressed. Then we have said, and they are usually represented by more than one unit. So derived units are represented by more than one unit. E.g., speed is measured in SI unit, which is meters per second. So speed is a derived quantity and it is measured in an SI unit, which is meters per second, represented by the symbol meters per second. So you have seen that here there are more than one unit. We have a meter and then we have a second that we are using to measure speed. So that's what basically um, derived units are all about. They are there to measure derived quantities and then they are expressed in more than one unit. So it is very, very important that you understand this. Now, let me now give you a table which is going to show you base SI unit, base quantities and then their SI unit and then base derived quantities and then their SI unit including the symbols, because once you master this table then you will home and dry. Okay, going to have um, base quantities, then we'll also have base SI unit, then we'll have symbol. Then we'll have also derived SI unit, then we'll have, derived, we should have here derived quantities, then we'll have now derived SI unit, then we'll have symbol here. Now this one is supposed to be in form of a table. Let's see if my marker will be able to give me a table. So let's see. So this marker is actually done, I'm sure. Okay. So I'll give you a few. Out of these few, you will be able to understand. Okay, let me also draw a line. So we have like it, base quantities. The first one we talked about was time. Time is a base SI or is a basic quantity. Now, what unit do we use to measure time? It is the second. Symbol small letter s. Okay. Then we go to mass, is a base quantity. What base unit do we use to measure mass? It is actually kilogram. What is the symbol? Capital K, small letter G. Next, we have length. Okay, it is another base quantity or basic quantity. What unit do we use to measure length? It's actually kilometer, or not kilometer, meter, sorry. It is meter. It is a meter here. Then what is the symbol? The symbol, it is a small letter m. Then the other one is actually temperature. Temperature, the SI unit is the Kelvin, like this. Symbol is capital K. The next is amount of substance. Substance. The unit is mole, like this. Then the unit itself, it is this small letter m, o, and l. That is a mole. Then the other one is actually light intensity. Light intensity. Then the unit for measuring light intensity is what we call candela. Then the SI unit is capital C and small letter D. Then another one is actually current. Current, the unit for measuring current is actually amps or ampere, and then the symbol of the SI unit is actually uh, capital A. So this is it for the base SI unit. Now we can decide to talk about these others like force, speed, volume, which are derived quantities. Like let's say force. Force is the derived quantity which is measured by Newton. Or either we can use Newton, but here it's very fortunate that we decided to give it Newton. But let me just tell you that even when we give it Newton, it's supposed to be actually this unit here, which is kg, um, because force is mass and acceleration, so it is supposed to be kg, then meters per second square. Now, this kg, because force by definition is equal to mass times acceleration. So the unit for mass is kg and the unit for acceleration is meter per second square. So this is where I derived this one. Now, this one has become the way it is, but we call this one as a Newton. That's why I said that. So this one we call it a Newton. And now a Newton is given by capital N. Then the other one that we can talk about is actually speed. Speed is a derived quantities which is measured in meters per second, which we write now as a small letter m and this per or slash, then we put small letter second. So that is the unit for speed, meters per second, which is written like that in symbols. Then we can also have this one, which is volume. So volume, which is measured in cubic meters, which is written as m to power 3. So these are the SI units for these again. Then another one is actually area. Area is measured in square meter, which is m to power 2. So that is the SI unit for meter. Then another one is maybe I can go for acceleration, which is measured in meters per second square, which is written like this, meters per second square. That is the unit for acceleration, which in other books they can say m s to the power -2. So that is either this one or that one is the SI unit for acceleration, and acceleration is a derived quantity. Then we can also talk about density. So density is a derived quantity which is measured in kilogram per meter cube. cube. This one should have been cubed or cubic. Yeah, this one usually confuses me. What did I put there? Cubed. So here it should be not cubic. I think it's cubed. Then here also cubed. Maybe they are the same. So this is kilogram per meter cubed, which is written as a kilogram per meter cube. So this is the SI unit for density. Then another one is actually power. Power has this one here, which is the watt, then capital W. Now, it's very, very important that guys you understand these things that I've taught you today here. So this table must be in your mind because if you think this is not very important, you get shocked because there are questions which come in an exam asking you maybe what is the SI unit for acceleration or power or speed or maybe mass, light intensity, current, or rather temperature. And then you need to understand that because without understanding this table, you won't be able to answer such questions. Okay. So guys, we have come to the end of this physics lesson. I think you enjoyed it as much as I enjoyed it. If you did, please, thank you so much. For now, bye and see you in the next lesson. Peace.